Hi, I'm Sara Aubery, a master's candidate at the University of the Virgin Islands. I'm studying corals and water quality. I want to ask the question, are coral reefs picky eaters?
I'll be studying the boulder star coral, Montastraea annularis, and its feeding abilities because I care about water quality. Corals are colonial animals where many individual polyps make up a coral colony. Inside of these polyps live symbiotic organisms called zooxanthellae. Symbiosis is an interaction between two different organisms living in close physical association, typically to the advantage of both organisms. The coral provides protection to the small one-celled algae, and the zooxanthellae provide food for the coral made from photosynthesis. We are losing many of the corals on our planet because of changes in water quality. Understanding how these changes affect corals on the inside may help us protect them better. Corals provide lots of amazing services to humankind, including homes and food for much of the seafood we like to eat. Corals in the tropics are the base of the food chain. They also provide protection of our coastlines from storm and wave energy. Plus, swimming among a coral reef is spectacular, and these reefs provide great recreation opportunities to locals as well as tourists. Sediment runoff from development on land, erosion, and stormwater contributes to poor water quality and harms corals. The coral colony primarily gets its nutrition through photosynthesis, and when water quality is poor, it may negatively affect the amount of light that can reach the coral through the water column. Without this light energy, zooxanthellae cannot perform photosynthesis, and the coral is left to fill a nutrition gap on its own. I want to know, when this sediment runoff reaches Montastraea annularis reefs, will this species be able to cope? Some coral species are able to use the tentacles found on their polyps to capture zooplankton and sediment particles from the surrounding water and ingest it as food. By observing Montastraea annularis and quantifying what happens to them physiologically under conditions of low light and high sediment particle concentration, I should be able to predict this species' sensitivity to turbidity. I will be taking small boulder star corals and placing them in a laboratory tank system. Here, I will be able to monitor changes in oxygen production and consumption, which tells me of the amount of photosynthesis that is occurring within the coral. Like any other animal, corals also store extra energy as fat. I can take small tissue samples from my experimental corals and analyze them for fat content. Changes in this fat content will help me figure out whether the coral is feeding heterotrophically if photosynthesis rates decline. With this data, I hope to inform watershed management plans and improve water quality conditions on the island of St. Thomas. Explore Brewers Bay and follow along as we get to know our corals over the summer. Learn about their physiology, come to environmental outreach seminars, and a high school field camp. Watch as I construct an elaborate tank system to house our corals and prepare them for a change of scenery. Observe the changes in feeding strategies using some really rad equipment and find out what happens inside when corals get exposed to mucky water. We are going to figure out just how sensitive our reefs are, so we can take good care of them, just like they care for us. Thanks for watching, because we're all here to learn about science. If you'd like to donate to this project, take a look to your right. There's lots of great goodies you'll receive for contributing. And money I raise on this site will go towards helping me purchase tank supplies, boat time to go out into the field, chemicals necessary to perform my lipid extractions, and other cool gadgets for measuring temperature, light irradiance, and coral metabolism. Thanks for watching. See you around.